We've gone through creating a confidence interval when sigma is known for a population mean. We have done it for when sigma is not known, and that's when we did t. And now we're looking at population proportions. And actually with this information, we can calculate a confidence interval for a population proportion. So if we look at a population proportion, we're going to take P, that's that proportion, and plus or minus the margin of error. To calculate error, we're going to use Z, and we're going to use a way of calculating standard error. Exact same thing as what we did with the other two examples. It's a little bit different calculation, and you have to ensure that your size is big enough. So to ensure this, what you have to do is make sure that you take n times the proportion. It should be larger than 5. You should take n times 1 minus the proportion, and it should be larger than 5. And if it is, you can use a z-score to calculate the confidence interval in this case. So again, we're going to look at it the same way. We're going to do plus or minus, and the confidence interval determines how much is in each one of those tails. So if we're doing 90% confidence interval, it would be 5% in each tail. In most cases, we do 95%, and that means 0.025 in each tail and a z-score of 1.96. So let's take a look at another example. And again, here's your calculation that I'll show you up here on the whiteboard here. Well, let's say there's a political science Inc. specialized in voter polls, and they're looking at doing a telephone survey to ask about registered voters who they would vote for if the election were held today. And they found out that 220 of those voters that were contacted favor one particular candidate. So 220 out of 500 is a proportion of 44%. So let's take a look at what information we currently know about this. So we have 220 individuals that stated that they are in favor of a particular candidate. That's out of 500 people that were called. That's a proportion of 44%. 220 divided by 500. You then want to create a confidence interval because we've only contacted 500 people. We're not completely confident that it's exactly 44%, but it could be plus or minus a little bit. So we can use a z-score that corresponds to 95%, and the calculation that we do then is the proportion plus or minus the margin of error, and the margin of error is the z-score times the standard error, which is actually a pretty easy calculation. It's just your proportion times 1 minus the proportion. You divide that by n, and then you take the square root. I want to make sure that we see that this is actually a square root here. That is a square root. So you take that at the end, then you multiply it out and add and subtract those two. So if I was to do the math here, let's take a look at it. You have the 0.44 plus or minus 1.96 times the standard error, and in the end it gives you 0.0435 as the total margin of error. You then add and subtract that to the 44%, and that gives you your population proportion confidence interval. And so looking at that, let's take a look up here. That means you have 0.44 plus or minus 1.96. You're then going to multiply that by the standard error, and standard error is going to be 0.44 times 1 minus 0.44. You're then going to divide that by 500, and then take the square root of that number. And when you do that and multiply it by 1.96, you get 0.0435. Add and subtract that from 0.44, and you get 0.3965 and 0.4835. So what does that mean? Well, that means that, yes, your sample tells you that it's 44%, but you feel 95% confident, and again, that means really confident, that it's probably between 39.65 and 48.35. So if there's two candidates, you can be pretty confident that this individual is less than the majority in this case. And the other person then would have to be either above that, as long as there isn't any people that are abstaining, right? So that's really how you do a population proportion confidence interval. Pretty easy to do, and real easy in terms of doing the hand calculation. There isn't really a way to show a quick fix in Excel, so you have to do this, but it should hopefully be relatively easy. You will be able to do this for any of these as long as it meets those two criteria, which is n times p is greater than 5 or n times 1 minus p being greater than 5. So again, this is the conclusion of what I wanted to show you in Chapter 8. Basically, 3 different ways of doing confidence intervals. One when it's a population mean that you're looking for, and sigma is known. One when it is unknown, that's when you use t. And then the one we just showed you using population proportions.